All right, welcome back. Well, before we take a look at the unit circles to see how you did with those triangles, what I'd like to do is talk about some angles and how do we know how to find sine, cosine, and tangent of angles without using the calculator, finding exact values. And if we know those key triangles, the 30, 60, 90 and the 45, 45, 90, we can actually do a lot of them in our head. And that's the key. That's the key to memorizing that. Let's take a look at some examples. So first, suppose I want to find the, I'm going to give a reference angle of 150 degrees. And I want to find the sine, cosine, and tangent. And of course, if I can find the sine, cosine, and tangent, then I would know cotangent, secant, and cosecant because of the inverse properties. So given 150 degrees, well, what do I know about a 150 degree angle? Well, if I graph it, 150 degree angle, it's going to be from standard position, it's going to be in the second quadrant, somewhere over here like this. Here is my angle, 150 degrees. But as I take a closer look at this, I'm going to ask myself, what's the reference angle for 150 degrees? And if this is 150 degrees, then this angle here would be 30 degrees. And now take a look, I've got a little 30, 60, 90 triangle. And I know the sides in a 30, 60, 90 triangle. I know that in a 30, 60, 90 triangle, this is 1 and 2 and root 3. The coordinates here would be negative root 3, comma 1. And 2 is the radius, the distance there. So now, when I ask myself things like sine, cosine, and tangent, it's all about the reference angles. So, what is the sine of 150 degrees? The sine is the y value over the r value. The y value is 1 over the r value of 2. So the sine of 150 degrees is 1/2. The cosine of 150 degrees is the x value over the r value. The x value is negative root 3 over 2. Oh, that should be a negative, shouldn't it? Negative root 3. When we think about the triangle, we don't often think about 30, 60, 90 as being negative, but because it is a coordinate, I put the negative there. Make sure that you understand that the negative cosine in the second quadrant here is going to be negative. And then finally the tangent of 150 degrees. Well, the tangent we know is the ratio of the y value over the x value. The y value is 1 over negative root 3. And if I simplify that, I'm going to get negative root 3 over 3 multiplied by root 3 over root 3. So these are the exact values. So we can do all of these reference angles, we can do them in our head. All right, let's take a look at a couple of other examples before we look at the rest of the unit circle. So for the next couple of examples, I'm going to put one up here. I want you to take a look at it, think about the angle, draw the diagram, and see if you can stay ahead of me on this one. So for the next one, let's look at the angle 4 pi over 3. So I'm mixing it up here a little bit I'm giving it to you in radians this time. So the first thing is I want to think about, well, where is that angle? What quadrant is that angle in? And what's my reference angle for this? What quadrant is that angle going to be in? Let's see, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. It's going to be down here somewhere. The angle is going to be somewhere over here. This angle is 4 pi over 3. Again, we want to take a look at, well, what is my reference triangle? As I take a look at the reference triangle here, what's my reference angle going to be? 3 pi over 3, my reference angle here is actually going to be pi over 3. And we should be able to think about these things as degrees and in radians. Pi over 3 is what angle in degrees? We should know that that's the same thing as a 60-degree angle, pi over 3. So if that's my reference angle, what are my coordinates and all my different values here? Well, the x value here is going to be -1. The y value is going to be -√3. The radius is going to be 2. So -√3 here and -1 here. Think about that as I ask the questions now. What is the sine of 4 pi over 3? The cosine at 4 pi over 3? And the tangent at 4 pi over 3. The sine, again, is the y value over the r value. The y value, I didn't put the coordinates here, did I? The coordinates would be -1 comma -√3. So the y value, -√3 over 2. Notice the r value is always going to be positive. Distance is always going to be positive. The cosine of 4 pi over 3 is going to be x over r. What's the x value? -1 over 2, so -1/2. And then finally, what's going to be the tangent of 4 pi over 3? The y value over the x value, which will be -√3 over -1, or just √3. All right, let's do another one and see if you can stay ahead of me on this one. And of course, since we know sine, cosine, and tangent, we know cotangent, secant, and cosecant. Those are just all going to be the reciprocals. So for the next angle, let's do something. How about, let's see. 1, 2, 3, 4, 5, 6. How about 7 pi over 4? 7 pi over 4. Okay, where is 7 pi over 4? What's my reference angle for 7 pi over 4 going to be? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi. 7 pi over 4 is going to be something like this. So there's my angle. There's my 7 pi over 4. Well, what's the reference angle now? Well, if I think about my reference angle, it's going to be pi over 4 here, negative pi over 4. Think about that as the coterminal angle. Negative pi over 4 is the same thing as 7 pi over 4. And we all should know that's also 45 degrees. So what are all my coordinates going to be here? And if we think about this, we should know that this is going to be 1 and 1 and the square root of 2. As a matter of fact, this is going to be -1, right? The coordinates here are going to be 1, -1. So again, what is the sine of 7 pi over 4? The cosine of 7 pi over 4? And the tangent of 7 pi over 4. The sine is the y value over the r value, which is going to be -1 over √2. Rationalize the denominator, -√2 over 2. The cosine is going to be x value over the r value, -1 over √2. Rationalize the denominator, -√2 over 2. And the tangent is going to be the y value over the x value, which is going to be -1 over 1, which is -1. So we should be able to do this for all of the different reference angles, which can make it a little bit difficult at first, a little bit overwhelming at first for all of the different reference angles, and there's a lot of them. All right, so let's take a look at the unit circle. On the unit circle sheet, these should be our triangles now. Again, the big difference now in the 30, 60, 90, 45, 45, 90, and 60, 30, 90 is that all of the radiuses, the distances, if you will, to the point on the terminal side of the angle are all 1 units, ones. So if I solve for all of these, I should get this. The 30, 60, 90, root 3 over 2 and 1/2, and 45, 45, 90, root 2 over root 2 and 1, and 60, 30, 90, 1/2, and root 3 over 2. And these, of course, would represent all the angles in the first quadrant. And if I know the ones in the first quadrant, I can reflect them into the second quadrant, and then the only thing that's going to change is the sign, S-I-G-N, sign, and then reflect those into the third quadrant and reflect those also again into the fourth quadrant. So we should be able to fill the unit circle out now. Take a closer look at that unit circle. As you go around the unit circle, the first thing you're going to do is you're going to put in all of the degree measurements and all of the radian measurements in the unit circle. And then think about each one of them as the triangles. And work on, and when it comes to the coordinates, work on the first quadrant only. So for the 30-degree angle, the coordinate here is going to be the x value, root 3 over 2, comma, the y value, 1/2. For the 45, 45, 90, the coordinates here are going to be root 2 over 2 and root 2 over 2. For the 60-degree angle, the coordinates here are going to be 1/2, comma, root 3 over 2. And then, of course, for 90 degrees, it's going to be 0 and 1. For 0 degrees, it's going to be 1, 0. For 180 degrees, negative 1, 0. For 270, all the way at the bottom, is going to be 0, negative 1. And then once you know the coordinates here, and then reflect them over and reflect them down. So we should be able to do this and finish the whole unit circle now. So the next thing I want you to do is I want you to finish that whole unit circle. Do the whole unit circle. Put it all together, the unit circle. So complete the unit circle. Work on it. Compare your notes. Check with each other. Make sure it's right. Make a nice unit circle. Take your time on it. The degrees, the radians. It will become something very important for us to study. And later we'll be able to answer all sorts of questions like, what's the secant of 5 pi over 6? Just by looking at the unit circle and knowing what secant is, the fact that secant is 1 over cosine, finding out what the cosine is there, taking 1 over that, and being able to convert between degrees and radians. There should be the flashcard game. Play that flashcard game as well. Go ahead and take some time now to complete the unit circle. We'll be able to use that at first. Will you be able to use that on the test? And the answer is no. On the Chapter 6 test, you will not be able to use the unit circle. But if you know where everything comes from and how to find everything, you should be able to find it. The more you memorize, the more you know, the better and quicker it's going to go. The next part of this section talks about looking at trigonometric functions in parametric mode. And we will do that. We will look at trig functions in parametric mode, but not in this section. We're going to completely skip that part of today's lesson. So there's not going to be any homework on that at all. But before we move on, I want to look at one more type of problem. Now, in the next type of problem, suppose I give you some information. Now, this is going to be a triangle that is not one of our nice, well-behaved unit circle triangles. So suppose I tell you, for example, that the sine of some angle is 4/9. Well, what do I know? The sine is 4/9, positive. So what quadrant could that angle be in? Well, sine is positive in 2 different quadrants. It's positive in the first and in the second quadrant. So right now, I don't know if this angle is in the first quadrant or if it's in the second quadrant. But I'm going to give you some more information. I'm also going to tell you that the tangent, whoops, I spelled that wrong. The tangent of the angle is less than 0. The tangent's negative. So now if I take the fact that the sine is positive and the tangent is negative, that tells me it has to be in the second quadrant. So what I want to do is I'm going to graph this angle. We're going to look at it and take a closer look at it. But the final question that I want to answer over here is, I want to know what is the sine of the angle, the cosine of the angle, the tangent, the cotangent, the secant, and the cosecant of that angle. Well, sine I already know. I know that's 4/9. And now let's be clever. If I know the sine is 4/9, what else do I know without doing any work at all? Well, the cosecant is inverse of sine. So if the sine is 4/9, the cosecant is going to be 9/4. I know that without doing any work at all. But what else do I know? Well, I'm going to draw a sketch of where this angle is. The sine is 4/9. The angle is over here somewhere. Sine is opposite over hypotenuse. So I want to draw where would 4/9 be. It's tangent's negative, so I know it's over here. There's my angle. The sine is opposite over hypotenuse. So I know that this length is 9, and the opposite side is 4. I know that that side is 4. Sine is opposite over hypotenuse, 4/9. I don't know this side right here. In order to find these ratios, they all require that I need to know the x value. So how do I find this missing side right there? Well, as you can imagine, Pythagorean theorem is going to help me. So a squared plus b squared equals c squared. The x squared plus 4 squared is 9 squared. X squared plus 16 is 81. X squared is 81 minus 16, 81, 71 minus 6 is what, 65, 75, 80. Okay, yeah, there we go. So x is the square root of 65. So the square root of 65. But what am I missing? It's going to be negative. If I take a look at these, in the second quadrant, I know that sine and cosecant are going to both be positive because all students take calculus. Everything else is going to be negative. All of these are going to be negative answers. All the rest of them are going to be negative. Well, what's the cosine? Well, here's my reference angle. Cosine is adjacent over hypotenuse, so negative root 65 over 9. Tangent is opposite over adjacent, so 4 over negative root 65. Rationalize the denominator. Negative 4 root 65 over 65. Now that I know these, cotangent, I'm just going to take the reciprocal of that. Negative root 65 over 4. Secant, I'm just going to take the reciprocal of that, is going to be 9 over the negative square root of 65. Rationalize the denominator. Negative 9 root 65 over 65. And there they are. Now notice I couldn't have done that until I knew this, because sine is positive in both of those quadrants. But the fact that tangent's negative means that it had to be a second quadrant angle, and then use Pythagorean theorem to find the missing side, and then I can find all that other good stuff there. For the next part of the lesson, we're really going to start talking about sine as its own function and sine as its own graph. And it can be kind of scary when we look at the sine graph. F of x equals a times the sine of b times x minus c plus d. This is a typical sinusoidal function. And I'm using sine here. It could be cosine, it could be tangent, cotangent, secant, cosecant. It could be anything at all. This is just typically sine here. And I want to just briefly talk about these different things, because I want you to, right now, to look at these through the through the eyes of transformations. All the different transformations is taking place. The A is something called the amplitude. And what it changes is the maximum and the minimum values. The B has to deal with the period. And the period is kind of a horizontal compression, either compression or expansion, horizontal stretching. The C value is something we call a phase shift, and it's a horizontal translation. And then finally, the D is something often referred to as the center line, and that's a vertical translation. In other words, the D value is just moving this whole thing up and down. The A value is stretching it, stretching the maximums and the minimums. The C value is moving it left and right, and the B value is stretching it horizontal. So there's a lot going on here, and it's going to take us a long time to kind of build up to this crazy sinusoidal thing going on here, but we'll start to take a look at the graphs in the next lesson. In 6.4. But for right now, I want you to stop the video and I want you to work on those unit circles. All right, good luck. Check them out. Make sure, make nice unit circles so you can use them to study from. Good luck.